So here's the problem I suggested you try to solve before me. Consider this cubic equation, p of x equals 0, where p of x equals this. Explain why x minus 1 is a factor, use long division, write it in this form, complete the factorization. Solve it using the null factor law. Why are there 3 solutions? So, here's my polynomial. How do I know x minus 1 is a factor? Well, if x minus 1 is a factor, then by the factor theorem, which is really the remainder theorem in disguise, then if I evaluate my polynomial p of x at x equals 1, I should get a remainder of 0. Let's try it. P of P of 1, let's evaluate the correct number, so what I wrote the first time, is 1 cubed plus 6 times 1 squared plus 5 times 1 minus 12. Well, that's 1 plus 6 plus 5, take 12, which is 0. And therefore, x minus 1 is a factor of p of x. So let's use long division. X cubed plus 6x squared plus 5x minus 12, and divide in x minus 1. So x into x cubed is x squared, x cubed minus 1, so it's minus x squared. Subtract. 6 plus 1 is 7x squared. Bring down the next term. X into 7x squared is 7x times. 7x squared minus 7x. Subtract. Oops, make sure that looks like a bracket, not a 1. Goes away. 5 plus 7 is 12x. Bring down the next term. X into 12x is 12 times. 12x minus 12, and that's exactly what I expected. I should get a remainder of 0. Okay, so now I have, let me show you the question again. So now I have p of x divided by x minus 1 equals this. So I'm going to write it in this form. Okay, I'm going to go p of x equals x minus 1 times q of x, my quotient. X squared plus 7x plus 12. Complete the factorization. Well, I can complete this because this is a quadratic. To factorize this, I need 2 numbers that multiply to give me 12 and add to give me 7. What 2 numbers multiply to 12 and add to 7? The answer is 3 and 4. So that means my p of x is x minus 1 times x plus 3, x plus 4. So now I have completely factorized p of x. The question finishes. Use the null factor law to solve this and talk about the 3 solutions. So, if my expression says this, and I want it to say 0 equals, well, the null factor law tells me that if I have a product of factors and it's equal to 0, then at least one of these factors must be 0. So therefore, x minus 1 is 0, or x minus 3 is 0, or x plus, whoops, that was a plus, and that's a plus, 4 is 0. Sorry about that. If this product is 0, then one of these factors must be 0. Now you've done this before with quadratics. That means x is 1, or x is negative 3, or x is negative 4. So, if x is any of these three values, then my original equation will be 0, will be correct, will be true. This polynomial evaluates to 0 at any of these three values, and that's why there's three possible solutions, because I had three factors here, all of which could be made to be equal to 0.